This lesson deals with Supplemental Problem 8.8. You can find this problem in the ECE202 ebook in the Chapter 8 Supplemental Problems on page 7. Given this impedance, could you evaluate it at 1 radian per second and find an equivalent resistance, equivalent reactance, an equivalent conductance, and equivalent susceptance? Could you use this to develop a model for Z equivalent at 1 frequency? Let's evaluate our equation at 1 radian per second. So we have 5 times 1 plus J1 times 3 plus J1 divided by J1 and then divided by 2 plus J1. That's right over here. Now since we're doing division, let's put things in polar form. So this is 5 at angle 0. The magnitude of this is square root of 2, which is 1.414. Angle is going to be 45 degrees because they're equal length. This one I have to use my calculator, so I'm going to put in that, and it'll square 3 and add 1 to it squared, and then take the square root, and that turns out to be 3.162, again a little bit longer than 3. The angle is going to be in the first quadrant, but less than 45 degrees because this is shorter than this, so 18.44 seems reasonable. J1 is just 1 at angle 90, and then likewise here we're going to be in the first quadrant, angle less than 45, so here's 26.57, and a length a little bit more than 2, so 2.236. So 5 times 1.414 times 3.162 divided by 2.236 turns out to be 10. And then the angle is 0 plus 45 plus 18.44 minus 90 minus 26.57. That turns out to be minus 53.13. So putting that into rectangular form, we would have 10 times the cosine of the angle, which turns out to be 6, and then plus j 10 times the sine of the angle, which is minus 8. Now that has a real part and an imaginary part. We call the real part the resistance, and the imaginary part the reactance. Now if we take the reciprocal of this, we'd have the admittance, and that would be 1/10, and then the angle would be plus 53.13. So again, multiplying this times the cosine of the angle, we get 0.06, and then multiplying 0.1 times the sine of the angle, we get 0.08. Again, the units here would be 1 over ohms or mhos. So our conductance would be 0.06 or 60 millimhos, and the susceptance would be 80 millimhos. Not the J, but just simply the thing that multiplies J. At 1 radian per second, this is the value of our impedance, so we could just form a series combination of 6 ohms and minus J8. With a frequency of 1 radian per second, that would have corresponded to a capacitance whose value is 1/8 farad. In other words, minus J over omega C would be minus J divided by 1/8 and then times 1. We could also take this result, which is our reciprocal of our impedance, and we'll be adding these two together like we added conductances in parallel in the time domain. So we'd have 60 millimhos. Now the reciprocal of that is 16.7 ohms, and then this would have a admittance of plus J 80 millimhos. Take the reciprocal of that, you get a minus J 12.5 ohms, which would correspond then to a capacitance of 1 over 12.5 farads. In other words, minus J over omega C would give you the 12.5 divided by 1. It's kind of interesting here, but at 1 frequency we could model our impedance as a series circuit or as a parallel circuit. In wireless circuits, we mostly work at 1 frequency. We're going to use this trick of conversion from series to parallel to do a lot of design and analysis. This is Supplemental Problem 8.8.